Perimeter means you take a shape and you add up all the edges. Let me give you a shape. I'm going to give you a real basic one. What shape is that?
Rectangle.
Is it?
Oh, it could be.
It could be. Let's go ahead and make it official. There you go. Rectangle. So let me give you some measurements on this rectangle. Let's call this side 5 inches. And we'll say this side down here on the bottom is 8 inches. So not a giant rectangle. Okay, here's my question. What's the perimeter of that rectangle? So to find the perimeter, the first thing you need to know is how many sides does this shape have? So you're holding up 4 fingers that has 4 sides, but I only gave you measurements for 2. So what are you supposed to do?
Know that the other sides are supposed to be equal.
They're supposed to be? Are you criticizing my drawing? Supposed to be?
True rectangle shape.
If it is a true rectangle, okay, fine. If I tell you this is a rectangle and you stop giving me a hard time about my picture. One thing that we know about a rectangle is that the opposite sides of a rectangle are the same. So if this lower part's 8 inches, the upper part here should also be 8 inches, right? And if the right side is 5 inches, we know that the left side then should also be 5 inches. Okay, great. So it has 4 sides, and now we know how long each one of those 4 sides is. So what do we do? Yeah, now it's just an addition problem. So the letter that we use for perimeter typically is P. So the perimeter equals, I'm going to do the left side, which is 5, plus the top, which is 8, plus the right, which is 5, plus the bottom, which is 8 as well. So 5 plus 8 is 13. 13 plus 5 more is 18. And 18 plus 8 is a grand total of 26. So the perimeter of this shape is 26 inches. Hey, that's not bad at all. Now what I want you to notice here is that when we wrote out the measurements for the rectangle, we had some duplicates. Actually, we had 2 duplicates. We had 2 5s, and we have 2 8s. Do you think that's true every single time you have a rectangle? Yeah, it should. It should be the same, right? The top and bottom should always be the same, and the left and right should always be the same, right? If I draw it correctly and you guys don't harass me for being bad at drawing. So we can actually simplify the formula for the perimeter of a rectangle like this. To find the perimeter of a rectangle, I would take the length of the rectangle, which is the going from left to right, the distance there, 8 inches. Take the length of the rectangle and double it. So 2 times the length of the rectangle. Then I would take 2 times the width of the rectangle, which is this distance going up and down, the width. I've got 2 of those. So 2 times the width of a rectangle. And if I find the sum of those 2 numbers, 2 times the length plus 2 times the width, that should give me the perimeter of the rectangle. Usually when you write the formula, we don't write out the words length and width because it takes a long time. So you might see this abbreviated as 2 and then lowercase l plus 2 lowercase w. And this right here is the formula for the perimeter of a rectangle. There's nothing wrong with finding all 4 sides and adding them up like we did originally, but if we can save ourselves the trouble of having to do some extra work, let's do it. Let me give you another example of what I'm going to conservatively call a rectangle. Don't make fun of my art here. This is a rectangle. You know it's a rectangle because I told you so, not because it looks like one. Say this is 3 inches, and let's call the top 11 inches. Okay. Just so I don't get a lot of harassment from the peanut gallery over there, I'm going to write rectangle, so there's no question. Rectangle. We could add up all 4 sides like we did originally, but let's try using our perimeter formula. Take the length and double it, and take the width and double it. Now, one of the advantages of using this equation here for the perimeter of a rectangle is that I don't have to write in the 2 missing sides. I can just use what I already know. So the perimeter equals 2 times the length. What is the length of this rectangle? It's 11, very good. Plus 2 times the width. What is the width of this rectangle? That's 3, excellent. So the perimeter equals 2 times 11, which is 22, plus 2 times 3, which is 6, for a grand total of 28 inches. That seem all right? Rectangle's not too bad. I feel like that's a fairly easy shape to deal with. Rectangle? Yeah, you agree? Rectangle's not too tough? All right, well, you may be thinking a rectangle's a pretty simple shape, but I bet I can come up with an even simpler one. And we will charitably call this a square. There we go, square. So I'm going to go ahead and say that this square, let's come up with a really big number. This square, that side is 50 units. So answer a question for me. Why on the rectangle did I give you the measurements of 2 sides, but on a square I only feel the need to give you 1?
Because they're all the same.
Very good. A square, all of the sides are the same, right? No big surprise there. So if I wanted to find the perimeter of a square, or really the perimeter of any shape that's got 4 sides, this is what I would do. To find the perimeter of the square, I would take the first side there, which is 50 yards. I would add the right side. Then I would add the top side. And then I would add the left side. So I could solve this problem by doing 50 plus 50 plus 50 plus 50. Can anyone think of an easier way to find the perimeter of a square besides doing 50 plus 50 plus 50 plus 50? Yeah, since they're all the same and I'm adding it 4 times, couldn't I just say that the perimeter of a square the perimeter is 4 multiplied by the side? That seems like that should work, right? Let's try it. The side here was 50 yards. So what I would do is 4 multiplied by 50 yards. Well, let's do 4 times 50. 4 times 50 is the same thing as 4 times 5 times 10. You can think of this as do 4 times 5 and then stick a 0 on the end. So 4 times 5 is 4 times 5 is 20 times 10 is 200. So I would expect the perimeter to be 200 yards. Good. Man, that doesn't seem bad at all. Rectangle, square, I feel like we've covered all the big ones. Can't think of a single shape left. I mean, square and rectangle, that's pretty much every shape there is, right? I can't think of any more. Oh, man. Triangle. You can give me a hard time about the triangle. My hand kind of wobbled on that first line. Triangle. Yeah, I forgot about that guy. Do you know why it's called a triangle?
There's 3 sides.
Did you say because it has 3 sides? Is it called a tri-side?
There's 3 angles.
It has 3 angles. Yeah, triangle has 3 angles. You could call it a trilateral, I guess. That would be the fancy way to say it's got 3 sides. So this is different from the square and the rectangle in one pretty major way. What's the pretty major way? Yeah, now there's only 3 sides, which means when I find the perimeter, I'm just going to add those 3 sides together. So the perimeter of this triangle is going to be 7 inches plus 6 inches plus 3 inches. So 7 plus 6 is 13, and 13 plus 3 is 16. 16 inches. Are we good so far? Yeah? All right. Do you know what this shape's called? It is a trapezoid. Wow. Very impressive. I can't believe you gave me a hard time about my rectangle, but you immediately said trapezoid. That's kind of messed up, actually. Do you know what a trapezoid is? The definition of a trapezoid? You know what makes a trapezoid a trapezoid? Huh? A trapezoid? If you don't know, you're about to learn something new today. Isn't that exciting? You're going to learn at least one thing. A trapezoid is a shape where the top side and the bottom side are parallel to each other. And the top and the bottom are parallel. Now, if you compare that to our rectangle, the top and bottom were parallel, but so were the left and right. Same thing with our square. In our square, the top and bottom were parallel, but so were the left and right. In a trapezoid, it's just the top and bottom, not the left and right. Anyway, not really relevant to solving this problem, but if it ever comes up on Final Jeopardy, now you're prepared. How do I find the perimeter of a shape that has 4 sides? Well, I would suggest adding the 4 sides together. So the top was 3 centimeters, plus the right side is 2 centimeters, plus the bottom is 6 centimeters, plus the left is 3 centimeters. So 3 plus 2 is 5. 5 plus 6 is 11. And 11 plus 3 is 14. So 14 centimeters is the perimeter of this fabulous shape. The trapezoid. Okay, so it's rectangle, square, triangle, trapezoid. Oh, we got a question. Hit me.
When you, are we supposed to show our work like this? How you put it out?
Oh, the question was, are we supposed to show the work? And the answer is, if you want to, you can show your work. If you make a mistake, showing your work is the only way to find that mistake. In other words, if I didn't show you this part at all, and all I said was a wrong answer, there'd be no way for us to know where the wrong answer came from. So showing your work, how you got the answer, number one, it's just good math practices to do that. Number two, it makes it easy to find your mistake if you make one. And number three, if you don't make a mistake and you get the right answer, showing your work is how you prove your answer, being able to prove you are correct. So that's a really long way to say showing your work's probably the best idea, but I don't think anybody's going to throw you out a window if you don't show your work. Well, I shouldn't say that. I won't throw you out a window. I guess I can't speak for everybody else in here. They might really want to see your work. All right, let me give you a shape that's not anything you're familiar with. I'm going to be really impressed if you can tell me the name of this shape. And the answer is not robot boot. That is not the answer. Just to be clear, you don't actually need to know the name of this shape to answer the question about the perimeter. I'm just curious if anybody knows.
Just call it a polygon.
Oh man, polygon. That is outstanding. What a great answer. A polygon can cover any of the shapes that we've drawn so far. Those would all be polygons. Excellent answer. Another way you can name shapes is by counting the sides. This one has 1, 2, 3, 4, 5, 6 sides. Does anybody know the name of a 6-sided shape? It's a hexagon. Very good. Now, you don't need to know that it's a hexagon, but what you do need to know is that it's got 6 sides. And the reason you need to know it has 6 sides is because when I start adding stuff up to find the perimeter, I need to make sure I'm adding 6 different numbers. So I can do a little bit of it. I know 4 of the numbers. Left side's 10, plus the bottom side, which is 15, plus this part of the right side is 7, plus part of the top is 9. Now I know that's not the entire perimeter because I left out 2 sides. Do you see the sides I left out?
Yep.
I left out this one right here, and I left out this one right here. I don't know how big those are. Man, I just have no idea. Could be anything.
6 and 3.
Whoa, 6 and 3. Let's start with the 6. Which one is 6? Are you talking 6 is the one that is horizontal, or 6 is the one that's vertical?
Horizontal.
Okay, so you're saying this is 6 feet. I don't disagree with you yet. Let's hear you support your answer.
How did you get 6?
Yeah. How did you get 6? Looks like wizardry.
9 minus 15.
9 minus 15?
Oh,
Yeah.
You mean 15 minus 9?
Oh, yeah. My bad.
Yeah, I like that. 15 minus 9. Here's why. This entire bottom side is 15, right? That means the entire top side has to also be 15. From this edge all the way over to this edge right here, that has to also be 15, right? This is bottom is 15, the top is 15. So far, so good? This piece right here was 9 of those 15 feet. This is 9 feet right here. So how much does this section have to be? 15 minus 9, 6 feet. And I can check my answer, make sure I did it correctly by verifying that 9 plus 6 is 15. That makes sense? So now I can add another number to my list here, plus 6 feet. I'm still missing one side, this one right here, but now armed with this technique that we did, I'll bet you could figure out this little section here. Because how tall from the bottom all the way up to the top here, how tall should that be? It should be 10, right? This was 10, so this should be 10. And this little chunk here is 7 of those feet, right? So how much is this little chunk going to be? That's going to be 3. So now I can add 3 feet to my running total of perimeter. Now, if I want to make sure that I got everything, that I didn't leave any sides out, all I'm going to do is make sure that I'm adding 6 numbers because we said the shape had 6 sides. So I've got 1, 2, 3, 4, 5, 6 numbers that I'm adding together for my 6-sided shape. So I know I'm in business. I got all the, I at least have the correct number of sides. All right, let's try it. Now, adding 6 numbers all in your head, like we've been doing for the last few, is a little tricky. So we're gonna break it down 3 at a time. 10 plus 15 is 25, and 25 plus 7 is 32. So I'm gonna group these 3 numbers together and call that 32 feet. Then I'm gonna group these 3 together. 9 plus 6 is 15. 15 plus 3 is 18, so that'll be plus 18 feet for my second group of 3. And now the problem's a little easier to answer because instead of trying to add 6 numbers together, I'm just adding 2. 32 plus 18. There's no shame in doing the old stack and add method if you don't have a calculator handy. Looks like 50 to me. So 50 feet is the perimeter of this hexagon. That doesn't seem too bad. Now there's one very special kind of perimeter that we haven't talked about yet. Very special kind of perimeter. It's so special it's not even called perimeter. It has its own name. What kind of shape is that?
Circle.
Circle. Thank you for being kind. Circle. Do you know what the perimeter of a circle is called?
Circumference.
It's called the circumference.
You also know the radius.
Say that again?
Not radius.
Well, that's coming. Radius is coming up in a minute. The perimeter of a circle is called circumference. Now, to calculate the circumference of a circle, you do have to have a little formula, which I'm going to show you in a second. But before I show you the formula, we have to know the name of some of the pieces of a circle. So I'm going to go ahead and label this circle with a couple of pieces. First, I'm going to draw a line going all the way through the center of the circle. Do you know what that line is called? That's called the diameter. The diameter is when you cut the circle in half. Okay? And then I'm going to draw another line here. Do you know what that line's called?
Radius.
That's the radius. The radius is half the diameter. Oops, can't spell diameter. Diameter. There we go. Finally, this spot where the radius and the diameter meet, right there, you know what that's called? Yeah, that's the center. It doesn't have a fancy name, I'm sorry to say. It's just called the center. Okay, now the reason I needed to tell you that, the names of those, is because there are two different formulas for finding the circumference of a circle, depending on whether you are using the radius or the diameter. Okay, formula number one, the circumference of a circle is equal to 2 multiplied by this goofy little symbol multiplied by the radius. The other formula, and these will give you the same answer, is this goofy little symbol multiplied by the diameter of a circle. So we're going to go ahead and label our pieces here. C is the circumference. R is the radius. D is the diameter. And that goofy symbol is called pi. It's called pi because the Greeks are the ones who came up with it, and that is the Greek letter P. So Greeks get credit for pi. Pi, the number. Pi, the delicious dessert, is, I believe, Egyptian. Now, pi is what's known as an irrational number, meaning the decimal after the 3 goes on forever, and does not repeat. There's no pattern there. It is seemingly just a random string of numbers. There are some calculators that have a pi button that do pretty accurate calculations for pi, but even calculators, even computers can't do pi exact because the number doesn't end. We don't need to be nearly that exact in our calculations. So for us, when we are solving for pi, we will generally use 3.14, or sometimes, in a fit of madness, we will use a fraction approximation, which is 22/7. Those are good enough approximations. Now, if you're trying to land a rover on Mars, you need to be a little more accurate than 2 places after the decimal. We will not be landing any rovers in class this semester. So for us, 3.14 is good enough. Okay. So I want to give you 2 examples of this, 2 circle problems, one using the radius and one using the diameter. So let's start off with this circle, and let's say the radius is 15 centimeters. I told you there are 2 formulas to use to find the circumference of a circle, and there are, but generally you use whichever one goes with the information you're given. If you're given the radius, you use the formula that has r in it, and if you're not given the radius, if you're given the diameter, you use the one that has diameter in it. Can anybody tell me how I could solve this problem, which clearly gives me the radius, using the diameter formula if I really, really wanted to?
Times it by 2, right?
That's exactly right. Since the radius is half the diameter, if I took this radius of 15 and doubled it and called it 30, I could use the diameter formula. That is why in the formula that uses radius, the first thing you have is multiplying by 2. It was 2 times pi times the radius, which is 15. That's why that one has 2 times and the other one does not, because we're taking the radius and doubling it to make it the diameter. So in a way, they're both the same formula, just look a little different. Okay, now how you write your answer, let's go ahead and multiply the numbers. 2 multiplied by 15 is 30. So I have 30 multiplied by pi. And this right here is the exact answer. What do I mean when I say it's the exact answer? I didn't round it. That number right there has not been rounded.
Oh, because pi continues.
Because pi continues. By leaving it as a pi symbol, I don't have to round it. I just leave the symbol in the answer. Yes, your answer actually has the pi symbol in it if I want the exact answer. That is it. You leave it just like that. You don't try to multiply if you want the exact answer.
So 30 would be just wrong, right?
30 would be wrong. It has to have pi in there. Now, if you don't want the exact answer, if you want what's called an approximate answer, then you'd go ahead and multiply it. I'd do 30 multiplied by 3.14. Okay? So let's go ahead and work that out. 3.14 multiplied by 30. Okay, the top's going to be all zeros. Okay, so I get 94.2. Is that what you people with calculators got? 94.2? Check my answer, please. $94.2 is the approximate answer. Why is it the approximate answer and not the exact answer? It's because pi is not 3.14. Pi is about 3.14. So when I multiply by 3.14, I'm not multiplying by the right number. I'm multiplying by a number that's close enough, but it's not correct. So this is an approximate answer. This is an exact answer. And to your average person, The approximate answer is much better. If I tell you 94.2, you know how big that is. You're like, oh, it's a little bit more than 94. If I tell you 30 pi, that's not as easy to wrap your head around. Like, what is 30 pi? Is that a lot? So the exact answer is really good when you have to be precise, and the approximate answer is really good when you have to speak to a human. In both cases, we would put the unit on there, centimeters, both for the exact and approximate answers.